we're going to be looking at the facing and pocketing toolpath pieces. We're looking at these together because they do almost the exact same thing. What you're going to find is pocketing is the one that you use most often. Facing is there, but it's not as useful. The difference between the two, facing will go outside of the lines that you're trying to cut. Pocketing stays within the lines. So got my stock, I've got my tool or drawings here. So I'm going to go to the Visual Mills Create, and I'm going to first create a facing toolpath. I'm going to select two curves. And so we have our two regions here. I'm going to, for my tool, I'm going to pick, in this case, I'm going to do a 1/4" ball mill, and I have the pieces over here. I have 280 inches per minute for MDF, so if we're cutting in that. So I'm going to go ahead and set this for the real 280. That's going to give my plunge rate around 60. I want the approach speed about 300, engage about 280. Retract, I can go ahead and put up to 300, and departure, I can put at 300. I'm going to use the regular rapid traverse. My clearance is the part max plus 25 or 250 thousandths. I'm going to use the clearance plane. I'm going to do, for roughing, I want to set my tolerance at 0.001 and stock at 0. I want island offset cuts or linear cuts. This is the direction that it's going to be going in. I like to use island, which means it's just going to go in concentric circles, if you will. Play around with this in simulation. It'll show you both of them. You can see the difference. I'm going to go for cut direction. I'm going to go climb, because eventually after the first cut it will be cutting air on one side and tool or material on the other. And here's a new thing, step distance. This is how far the tool is going to step over between each pass, because it's going to be clearing an area. Since I am using a ball mill, I want to set this for fairly small. 25% is not bad. The larger this is, the larger the little V-shaped grooves are going to be that the tool leaves behind. If you're using an end mill, you can set this as high as 50% of the tool, or even 75%. I'm going to do a corner cleanup so it goes back and hits the corners and make sure those are set. I'm going to go to cut levels. This is very similar to what we've seen before. I want my geometry at the top. I'm going to do cut depth at, well, we'll go ahead and do the 600 thousandths. My roughing depth, I want to go ahead and do 500 thousandths for it, which will give me a finished depth of 100 thousandths. And for roughing depth of cut, remember, I don't want it to go over one diameter of the tool in most cases, so I'm going to go ahead and set 250 thousandths here, since it's a 1/4" cutter. And then the last cut is going to make at 100 thousandths, which will make the tool not stress as far, and so it'll give a nice finish to those. Next is down here, cut level ordering. You always want to set this to depth first. If you set this to level first, what it'll do is it'll cut 250 thousandths in one block. It'll move over to the next block, cut 250 thousandths, then move back, cut the next 250, then this, then do the finished depth and back. And that just takes forever. So depth first works a little better. It wastes less time switching between cuts. Exit and entries, again, you can play around with this. I'm going to use a long 3D entry this time, just to show you the differential here. I'm still going to do exit motion as none. Just let it come straight out. Works really well. Advanced cut parameters. We really don't need to switch anything here. Everything is good as it is. Then we're going to hit generate. And you'll see here that it is computing. And notice how much longer this took than, say, profiling. And I'm going to go in and I'm going to look at the simulation, but before I do the simulation, I want to do a pocketing cycle on these two so you can see the difference. So I'm going to create a pocket. Again, I'm going to select my curves, and notice here that I had these two already selected, so what's going to happen when I hit this, I'm going to end up with 4 regions. So I don't want to recut the first two, so I'm going to select those and remove the active. Select region 1, remove active, see how they become unhighlighted. For tool, I'm going to use the same 1/4" ball mill, and most of these things are already set from the last cut, so my cut speeds are already set, my clearances are already set. Cut parameters, I want to set the tolerance again to 0 or to 1/10,000ths, stock to 0. Offset cuts versus spiral or radial cuts, linear cuts. Offset will try to follow the shape of the piece. Spiral starts in the center and just works out in a spiral. I typically cut these with offsets. Cut direction, I can let it do mixed, climb, or conventional. Again, since it will be air cutting at some point, climb milling works very well to give a better finish. I want the start point inside, and it's indicating here my start point. Step distance, again, is how far it steps over, so I'm going to leave this at 25%, and I'm going to do corner cleanup. Cut levels, I've got at top of geometry. I'm going to cut this again, just like the other, at 600 thousandths. I'm going to give a roughing depth of 500 thousandths, which give me a finish depth of 100. I'm going to cut on the roughing depth 250 thousandths per cut, and that'll leave the last cut cutting at 100 thousandths. I'm going to make sure I leave depth first, so it's a little faster. I can change the approach of this, and this is path, linear, or helix is how does it enter into the path when it starts cutting. If I do path, then it'll actually ramp down into it. So I want, and I can select how long that path becomes. So I'm going to leave these as is. I don't want to apply entry and exit at all cut levels because I want to go ahead and have it clear out. And here as retraction motion, notice here it shows the angle that it retracts goes away. I want to set this at 0 or it's going to give me a little ramp coming out of my part. So I want to set that angle as 0 so it comes straight up. Advanced cut parameters we're fine with. Sorting we've already talked about, so I'm going to generate. Then I've got my 2 pieces here. I'm going to go to the visual mill, and I want to highlight both of these pieces by selecting the set. And so once I do that, it's going to simulate both of these tool paths. If I selected just one of them, it would simulate this but not this. So I'm going to select the whole set, go to simulate, I'm going to hit simulate, and there it's cutting my first level. Here it's cutting the second level. Then we've got the finished level cutting. And now remember, these two are the facing operations. Now it's going to start on my pocketing. Here's it cutting the pocketing piece. And going into the second, remember I started on the inside, so it started at the beginning and it's cutting out. Now if I zoom in on these, and once my simulation is finished, you'll notice that I don't actually see the cuts anymore. The reason for this is it doesn't want to show me all the tools in a set at one time. So if I click on, after the simulation is finished, if I click on one of these, you'll see I see the simulation for it. I can also come down here and turn off the tool path, that's that blue line, so that I just get the hollow space. And so if I click on zoom window, I can come in here and look at it. I can even rotate it around to see how it's going to look. Notice the little grooves in the bottom. That's determined by the step over. So if we decrease that step over percentage, those lines would get closer together and the ridges would get smaller. Also notice these yellow lines, those are the original part lines. This is the facing function, so it went out beyond the line so that the inside of the line was perfectly flat. If I go in and go to the pocketing, now I can see that set of tools, and I get a lot of the same things since we use the same parameters. However, notice that my border line, my box that I used to cut, is the exact edge of this, which means since I'm using a ball mill, the actual flat space in the bottom is smaller, and I have little radiuses at the corners. So that's the differential between what you'll get between facing and pocketing.